Hello, I'm Ishizuka Yoshihiro from Geological Survey of Japan. I would like to talk about contribution to volcano disaster prevention based on geological mapping. Case study on Fuji volcano. This picture shows the Mount Fuji summit in summer. Mount Fuji is highest and biggest in Japan. 300,000 climbers visited this summer every year. The most recent eruption of Mount Fuji occurred 1707. It was an explosive eruption with the ejecta volume of 1.7 cubic kilometers. Historical records and geological survey indicate that basaltic scoria was deposited in the Tokyo metropolitan area with thickness range from few centimeters to 10 centimeters. When Fuji is erupted, metropolitan area will suffer great damage. Fuji Volcano Disaster Prevention Council 2004 estimate economic damage would amount to about 2.5 trillion yen, $19 billion, if a volcanic ash fall of same scale as the 1707 eruption occurred. This shows research system for volcanoes in Japan. Scientific research carried out National Institute and university both, and we Geological Survey advised to Disaster Prevention Authority, especially Japan Meteorological Agency, JMA. JMA will advise local government and public with their information and alerts. Timescale volcanic phenomena are studied on the variety of timescale, ranging from months to millions of years. Geology can deal with activities such as volcanic growth and caldera forming. These activities occurred on timescale of 100 to 1,000 years. These studies can contribute to prediction of volcanic activities in the medium and long term. We also contribute to disaster prevention and mitigation by making geological maps and database available to the public. Volcanoes are arranged in relation to these subduction direction. These are about 460 quaternary volcanoes in Japan, which has been active since 2.6 MA. This is a variation of volcano from basaltic small volcanoes and large Bright caldera. Here are some variation of volcanoes. Fuji is a large basaltic stratovolcano nearly 4,000 meters above sea level. Mount Ontake is a composite andesite dayside volcano. It is a typical volcano in Japan. Towada is a violet caldera. All of quaternary volcanoes in Japan are not always active. In Japan, active volcanoes are defined as past 12,000 years in world's Holocene, or with intense phonolic activity. There are 111 active volcanoes. Among them, 50 volcanoes are continuously monitored by JMA. GSJ published 22 geological maps of volcanoes, like this, including Fuji. Geological survey was conducted using a combination of new aerial laser survey and a typical surface survey. On the lava flow side, a small excavator was used to excavate trench like this. At 146 sites, Chaco's paleosoil were determined the age of eruption for Fuji like this. The vicinity of the craters, scoria cones, excavators are not allowed. So trench up to 32 meters in depth were excavated by hand to determine the age of eruption relative to volcanic ash layers. In doing so, we revised geological map for first time in 48 years. It divides into 194 geological units. Colors are shown as red are lava flow, younger than 2,300 years old, and green and blue are older lava flows, and yellow is pyroclastic flow and lahars, and brown indicates debris avalanche. Most importantly, the location of crater, the age of eruption, and the scale of eruption in the last 8,000 years were clarified. There have been 89 craters and eruption fissures. Based on this information, the hazard map was completely revised. On the left is a 2004 hazard map, and the right is the revised version. In particular, it showed the assumed craters spread like this, and associated eruption scale. Based on these initial conditions, simulations of lava flow and pyroclastic flow have been conducted and published. Excavation plans are currently being developed by local government. The following is examples of recent eruption in Japan. At first, Kirishima eruption 2011. The photo shows cities located 27 kilometers east of the volcanoes 2 days after the eruption. Volcanic ash more than 5 millimeters thick was accumulated in the city with a population of over 100,000. GSA started an emergency survey the day after eruption, based on our experience in geological survey. How large is eruption? Magmatic eruption involved? What is the future of magma? We focused on these questions. This is ice map showing extent of pumice and ashfall deposit during 2 days. Iceberg map allows us to estimate eruption mass expiring from the crater. Estimated volume about 70 million tons, 10 times of the pyramid of King Khufu. Then scale of the eruption is severe. The second case is 2014 eruption of Mount Ontake. Eruption scale itself was small, but 64 people killed by ballistic bomb. Most of victims were hikers who were staying near the summit on Saturday around noon. Eruption crater was very close to summit. This photo was taken 1 month after the eruption, when volcanologists were able to enter to area for first time to investigate. We can see the roof of the mountain huts held by many ballistic bombs. This shows characteristics of the victims for volcanic eruptions in Japan during the last 70 years. Characteristics are as follows. Sudden explosive eruption near crater, mostly phreatic eruption, caused fatal accidents. Visiting people are sacrificed. In words, eruption alert system for visiting people is not fully provided. This is on record. This is a recent issue in Japan, and research is underway. This is summary. Highly accurate geological mapping contributes to hazard map that lead to the evacuation of residents. GSA is using its knowledge of geological mapping to conduct emergency survey at eruptions. We provide data to JMA and make result available to residents, to media. Thank you for attention.